In class today, we learned that when the frequency of a wave goes up, the wavelength gets shorter. So the wavelength comes down. But as the wave gets less frequent, the frequency comes down. The wavelength gets longer, it goes up. There is a formula we will use that expresses this idea, and in this video, we are going to learn how to use this formula to solve problems. This formula is the wave equation. The wave equation goes V equals lambda F, where V is velocity, how fast a wave travels. Lambda is the wavelength, how long the wave is. And F is frequency. Frequency, which is how fast the wave swings up and down. In terms of units, meters per second for velocity, meters for wavelength, because wavelength is a type of distance, how long the wave is, and the unit for distance is meters. And finally, the unit for frequency is a hertz, which is Hertz, which we simplify as Hz. So once again, our formula is V, velocity, equals wavelength times frequency. When wavelength goes up, frequency goes down. When wavelength goes down, frequency goes up. Let's try a sample problem. A sound wave with a frequency of 680 Hertz is moving at a speed of 340 meters per second. What is the wavelength of the wave? The first step is always to circle what we are trying to find, what the question is asking us about. To figure out what the question is asking us to find, we look for the question mark. So the last sentence is a question. It is saying, what is the wavelength? So wavelength is what they are trying to ask us to find. One hint is that when you see something like what is, what comes right after is what we're trying to find. So I will circle wavelength. That is what we're trying to find. Wavelength, because we do not know what it is, I will write lambda, which stands for wavelength, equals question mark. We don't know it yet. Next, second step, we underline other pieces of information that they give us. The numbers are always important. We know that 680 Hertz is given. We want to know what that is. We look a little bit to the left. It says frequency of 680 Hertz. So we know that 680 must be frequency. We also know that Hertz is a unit of frequency. That's another clue we can use to know that the frequency, or F, is 680 Hertz. Finally, it says 340 meters per second. And it says speed. Speed is the magnitude, or how big velocity is. Also, the unit of velocity is 340 meters per second. So we know V is 340 meters per second. Now we can go to our formulas. There's only one formula that has lambda, F, and V in it. And that formula is the wave equation, what we are learning in this video. V equals lambda F. To solve this problem, what I will do is, we start with the V. I will draw down here. I'll draw an arrow to indicate where the numbers come from. I know what V is. V is 340. So under the V, I draw an arrow and write 340. The equal sign stays as the equal sign. The lambda, we don't know. If you do not know a number, you write lambda. Frequency, we know is 680. So underneath the F, I write 680. And we know that it's lambda times frequency. Let me erase the question so we have more space to continue this problem. There we go. So we know that our equation is 340 equals lambda times 680. We are trying to solve for lambda, which means we want to get rid of the number next to lambda, or 680. We have lambda times 680. To get rid of the 680, we divide both sides by 680. The 680s cancel. So I know lambda is 340 divided by 680, which is 1/2, or 0.5. The unit for lambda, which is wavelength, is meters. And there we have solved for lambda, which is the wavelength. So the answer to the question is the wavelength of the sound wave is 0.5 meters.